All right, thank you for joining us today, folks. I'm Kelly Hill, editor with RCR Wireless News, and we're going to be talking about building the mobile Agile network today. My participants today are Patrick Lopez, CEO of Core Analysis, Michael Rezek, VP of Business Development and Strategic Partnerships at Accedian, and Nick St. Pierre, who is VP of Office of the CTO at Sandvine. So we're going to go ahead and get into the presentations. Just so that you know, we will have a couple of polls asking your opinion on a couple of aspects of this, and we will have Q&A at the end. So please feel free to submit your questions, and we will get to them at the end of the presentations. So let's start out with a look at the landscape for mobile networks. We're really looking at network transformation. We're talking about increasing complexity when you think about 2G, 3G legacy networks and the LTE RAN. New services, including VoLTE. You've got SDN and NFV in the mix, as well as cloud applications and services. And the industry is already looking toward 5G and what that's going to mean for the network. Increasing density. Now, these are some numbers from Nokia and that I thought were really interesting. And, you know, from their perspective, they're thinking about a level of density, 1x macro site, 5 to 10x outdoor micro sites per macro site, and then 10 to 100x indoor Wi-Fi cells or small cells per macro site. And that's within 1 square kilometer, and so that's pretty incredible network density that vendors are anticipating. We're talking about a dynamic network environment. IHS and Phonetics reported 26% growth in SON demand between 2013 and 2014. So we are seeing self-organizing networks, really start to get some growth there, and they do expect a compound annual growth rate of 7.6% until 2019. In terms of traffic growth, from the Ericsson Mobility Report 2015, 5.3 exabytes per month in 2015. Growing to 51 exabytes a month by 2020. That's a 45% compound annual growth rate. There are different numbers from Ericsson, from Cisco, and others, but the growth is a common denominator. When we also talk about network transformation, we're also thinking about a more dynamic and variable network environment in terms of different types of traffic. You've got some that's more chatty or bursty. You've got things that need priority like VoLTE, others that need high availability. And as we get into IoT, we're talking about general IoT traffic versus some that may need, very high priority, or real time if we're talking about, remote surgeries or safety and manufacturing and some of those. And so, really it's that increased diversity in traffic, density, variability, and a dynamic environment, and then many more types of applications and users, and yet still dealing with very tight and tighter performance specifications. So as part of that, I think we're really seeing the rise of analytics to try and deal with these network conditions. If you look at the overall telecom analytics market, that's expected to hit $4.2 billion by 2020, and that's in sort of all the areas of customer/network/business intelligence. Network analytics alone is projected to hit $1.9 billion globally by 2020, and that's largely driven by communication service providers and cloud service providers. And so when you think about what that means for the people who run the network and what that means for network systems, and this is something that I found from Raymond Papuk, who's Chief Product Officer at a security company called ProtectWise, and thinking about different network point products, really being able to overwhelm the human element of network control. Add to that the fact that advanced humans are in short supply, particularly when it comes to, big data analytics. It's not necessarily easy to fill that part of your workforce. But really when it comes to visibility and detection and response to what's going on in the network, I thought this was a great quote: "The network does not lie and holds the clearest picture of what's happening. You just have to be able to get to that picture." From analyst firm Global Industry Analysts, that there's this idea that instantaneous information analysis creates value, unrivaled by the conventional method of generating activity reports on a monthly or weekly basis. So it's really about getting to a better, faster snapshot of what's going on in the network now. I'd like to start you guys off with a poll as we move into the next presentation from Patrick Lopez. And we'd like to ask you about a QoE. All right, and we're going to leave that poll up for a bit. And Patrick, do you want to go ahead and go take it away?
Absolutely, thank you. Next slide, please. So I think we certainly have touched upon the fact that there are an unpredictability that's rising from the network due to consumer behavior and due to the fact there are new services that are emerging. So on the right side of that slide, I mean, we've talked about a few of those things already, and certainly, you know, between smart cities, autonomous vehicles, augmented, virtual, or mixed reality, Internet of Things, there is a certain or large degree of unpredictability here. We're building a network, but basically we're seeing that there are services that are now in the domain of the possible that are going to happen within the next 5 years, 2 years to 5 years. And those services, it's really difficult to predict what their impact is going to be on the network. At the same time, I think that it is worth noting that a lot of what people call the over-the-top providers that created services, digital services basically on the internet, are seeing their business model change as well. I think that, you know, in the case of Facebook and YouTube and Netflix, they created those services for the internet with the assumption that people were using those services basically on their computer on a fixed line broadband access. Now, increasingly, those services are being transported into the mobile area and the mobile network. And the numbers that you have here for Facebook are not from yesterday, they're from the previous quarter. But in the previous quarter, Facebook basically had 47% of their users that were mobile only. So they accessing Facebook only on the mobile phone, not only on the computer and a mobile phone, only on the mobile phone. And that has generated, again, in the last quarter, not yesterday's announcement, close to 78% of their revenue. So Facebook, which was just an internet company, now increasingly have to think that they are a mobile company. And that's true pretty much across the board. And we have here Google's YouTube that sees half basically of its view now on a mobile device, and close to half of the Netflix 18 to 34 years old demographics are watching the service also exclusively on their mobile. Now, watching on a mobile doesn't mean necessarily watching on a mobile network. Obviously, there's a fair amount of that traffic that is on Wi-Fi, but it is important to note and understand that it is increasingly cellular, and that together with 4G penetration and in the near future with 5G penetration, we will see more and more of the service on the mobile network, on the cellular network. And obviously, all those trends have to have an effect on how we build those networks. Next slide, please. So basically, you know, all those OTTs, all those content providers that created content and services for the internet moving into the mobile space are leading to the growth that Kelly was alluding to earlier. We've all seen the numbers. Data is growing, and within data, video is the fastest growing digital service on mobile. At the same time, we've seen pressure regarding net neutrality and privacy that has basically led to two things. On one hand, some net neutrality provisions in some countries basically saying that network operators should not, in any shape or form, affect the traffic flow and certainly not provide any prioritization of one type of traffic versus another, and no throttling. And at the same time, we have seen from the content providers and aggregators and from the service providers an increase of encrypted traffic. So more traffic and more encrypted traffic without a way to actually manage that traffic leads to poor quality. And we don't have all the numbers here on that slide, but we all know that video as a service in a mobile network is not a very good service. It stalls often, it takes time to start, people have a high abandonment rate, and basically for a service which is the dominant service on a network, video, that is the growing fastest than any other service, having that service being the lowest quality basically compared to voice and browsing, etc., is certainly a problem for everyone involved in the value chain. And when I talk about the value chain here, it's not surprising that that poor quality leads to low yield in terms of advertising revenue. And those advertising revenue in mobile networks specifically are not going to be able to sustain the growth of traffic, which is basically going to sustain the growth on investment. So right now, network operators are looking at some point in time at an unsustainable cost structure. They're looking at their cost growing due to the growth of traffic and their revenue not necessarily growing. So what does that mean for network operators? Well, they need to, on one end, a new architecture, so enter SDN and network function virtualization that are going to, on one end, reduce the costs as well as make the network a lot more flexible and a lot more agile to be able to respond to peak demand and also to respond to the different type of use cases that we saw in the previous slides. But the corollary of that is certainly that because of all these new services, some of those services are operator-led, but a lot of these services are led by third parties and OTT providers. Network operators will have less and less capability to measure and manage the quality of experience, unless they build a network that is actually designed to take action based on quality of experience. So quality of experience and quality of service measurement until very recently were more functions of the network that were added as an afterthought. And maybe I'm being a little derisive here, but it wasn't really the priority. Right now, we're seeing that increasingly subscribers are starting to select networks and network operators based on quality. And I think that we've all seen the results in North America here of T-Mobile over the last couple of days. They are one of the only operators that is adding new subscribers, and it's certainly based on their communication, their services that are quality oriented. So being able to differentiate in the new world, in the next generation of network, is going to mean being able to measure and manage quality of experience. As those new services roll out and as SDN and FV increases the layer of the complexity because of the layers of that are being put upon the network in terms of abstraction, then you need to start thinking about how to measure and manage quality of experience at the design phase. Next, please.
Thank you, Patrick. So given the challenges and the variety, the diversity of the traffic and the services that are now being carried over the same pipe, mobile networks really are going to need to become more dynamic. And rather than being the infrastructure being dependent on the pipes and the links and being centered around that, really becoming more service-centric so that they can adapt to the new demands that are being placed on it, as well as trying to derive new revenue streams, new opportunities out of this network. So the MSOs are now considering and moving toward a more highly virtualized, software-defined network architecture in order to achieve the cloud-like benefits such as scalability, agility, and elasticity. And I'll just take a moment to talk about those three terms, scalability, agility, and elasticity, because we throw those terms out a lot and throw them around a lot, but what do they really mean? So scalability, obviously, is the ability for the network to meet the expected demand for services without the need for the large upfront investment in infrastructure. And that's going to become increasingly important, especially as we look ahead to 5G. There's a lot of conversation around 5G and even the next generation of 4G. The LTE links being used as backup lines for businesses and so forth. So there's going to be an increased bandwidth demand being placed on the network. And so scalability is really going to be important in order to be able to capitalize on a very dynamic demand on the network for bandwidth. Agility and the network becoming more agile, that means the ability of the network software and hardware to automatically configure and control itself and the other network access across a number of devices on the network to support the network services themselves. And then network service elasticity. So when we talk about the network being elastic, it's really a way to enable the operators to dynamically adapt to the variability in demand of the service based on the demand for the consumption of that service. So what this means is that the network will now begin to optimize the quality of experience on the per application basis, given the MNOs defined policies. And the SDN control itself is going to depend on analytics, on machine learning, in order to synthesize the optimal network configuration in real time, moment by moment. And then the real-time knowledge of the network state, the traffic policies, the user experience, is going to require that there be visibility at all layers. So when you kind of look here at the traditional control plane, data plane of SDN in a virtualized environment, what we're also saying is the instrumentation layer is going to become increasingly more important, more valuable, because without it, you do not have the visibility that you need to the network state ubiquitously across the network at various points. You know, as I always say, you can't control what you can't measure, and you can't measure what you can't see. So this instrumentation layer is going to play a crucial part in the closed loop control of network automation and providing that data back to the control plane.
I guess what we can derive from this is we need to build networks maybe a little bit differently from how we've been building networks in the past. And a good example or a good analogy is maybe to look at how industries and players that have had to meet the same challenges have dealt with them. And basically, if we look at Google, and you know, they've gone through 5 different data center architecture, and they're on the Jupyter one now. A typical data center of Google has 5 different fabric architectures in production, and is usually featuring about 10,000 nodes, 250,000 links, and over 10 million rules, policy rules, provision across. That's at the scale of one data center. So I don't know if you can imagine, and I certainly can't, even though I saw it. You have obviously a very high level of complexity. The level of complexity arises by just the number of links and the number of rules, but simultaneously there has been a level of complexity that has been removed by the fact that, you know, they've reduced drastically the number of type of servers that they have to deal with on a physical layer. So in order to run such a data center, basically, they have to put in place a number of models for measurement and for control of the physical architecture, and obviously, on top of the physical architecture, the virtualized architecture. And they want, or they rather are deploying capabilities at a telemetry layer to be able to check any server, any port within any server, at the SDN layer to understand the network topology from a virtualized and from a physical layer, and how the physical and the virtualized translate into each other. Obviously, they have the ability to trace issues from the physical to the virtual and to do troubleshooting. And generally speaking, when you run a data center such as one of Google, their objective, their primary objective, is to have homogeneous capacity. So across those 10,000 nodes and their 250,000 links, they need to be able to have a predictable model and predictable capacity, at least at the transport layer before the control layer, throughout that data center. And what that means is basically they have been working at the transport layer on iteration of the protocol itself, so modification to TCP and UDP, but also on a number of layers that are enabling visibility of how the physical and the virtual networks behave. What does it mean? It means that at a high level, there have been implementing virtual probes and virtual telemetry capability within each and every one of those servers, each and every one of those links, and at each end of each and every one of those rules. But you cannot run a network with 10 million rules and 250,000 links, sending several times a second signal through all those physical and virtual components. They still don't have the scale to manage that kind of control signaling and to process it in real time. So the way they're looking at it is basically having semi-randomized end-to-end proactive tests that are going on from one host to one client, and one client to another host several thousand times per second throughout the data center to kind of triangulate the data center's performance and its capacity to cope with the traffic. And when there is a result that is outside of the accepted norm, then that node or that server or that rack or that virtual instance are segregated, starved, and eventually quarantined for further offline processing, so that a failure cannot cause catastrophic failure throughout the system, but more importantly, machine learning can ensure that any results that is outside of the norm can be analyzed and then fed back into the fabric itself. Netflix has introduced a very interesting way to look at failure. They feel that a network, by definition, will have failure, and any component at any time can fail. Therefore, their philosophy is that they've been creating very intelligent failure induction tools that are going to inject failures within the system. Those failures are not going to be random. They're going to be in specific places, for specific functions. The guiding light is basically looking at what type of failure have what kind of effect on the consumer, and basically they always try to reduce the impact to about a dozen possible live sessions. And all those failures that are introduced by Netflix into their own fabric are meant to provide feedback on how resilient the data center and the platform is, but more importantly, they uncover causes for failure that they haven't thought about before. And that's where the machine learning is coming in. I realize that that's a lot to absorb for a single slide, but I think that my conclusion on this is that if you are thinking about building a new network, a next generation network, you have to rethink how to address telemetry and how to address quality of experience management. And the best way to do that is to look at that from the design phase. And from the design phase, you have to be able to deploy physical and virtual probe functionalities throughout your network, throughout your fabric. It doesn't mean that all those probes are going to be reporting all the time. It doesn't even mean that all those probes are going to be active all the time. But you need to be able to inject those probes where you want, when you want. And then beyond that, you need to have a strategy for testing your network proactively and inject errors within the network, because errors are going to happen anyways. But it's better to inject your own errors in a controlled environment and measure the impact, so that when unwanted errors occur, then you have a frame of reference. You have a database of all sorts of errors that you have injected in the past and their associated consequences, so you can identify, isolate new errors fast, and then feed that back into the machine so that it can learn by itself and be more resilient.
Okay, let's move on to talking about instrumenting the mobile network. Michael, is that you?
It is. There we go. So as I mentioned earlier, and of course, Patrick did a great job of just describing the need for a, kind of what I call more of a ubiquitous instrumentation or a pervasive telemetry, whatever you want to call it, but the ability to instrument a network with the types of probes and agents in order to gain visibility. Because in a network-based service, you don't have the luxury of being confined to a data center where everything is able to be deployed across a fabric, but you're actually going over land and sea and sky to deliver these services. So it's important that as we look at instrumentation and we look at concepts of virtualized infrastructure, SDN, NFV, the instrumentation itself needs to be virtualized. And so you apply the same principles to SDN, NFV, distribute the monitoring plane with the least or even no hardware, using virtual agents, for example, and using NFV to augment KPIs and virtualize and centralize the control function. So if you look over on the right there, we kind of show some different ways to do this. Some are hardware based, using SFPs. You can also use virtual NIDs, virtual agents and software to run and capture metrics that can then be transported back to a centralized control system and even into the analytics layer for analysis. Next slide. So in talking about this concept of pervasive telemetry or ubiquitous instrumentation, you want to do this in a way that you address the entire service life cycle. So a couple ways you can do this. One, of course, is active testing, and then, of course, there's passive testing. Let me just take a minute to talk about the difference between the two and some of the benefits and detriments of each. So active testing can be effectively deployed using virtualized instrumentation to pre-assess network readiness, locate bottlenecks that could impair, for example, if you're delivering VoLTE QoE, and continuously monitor QoS to derive user experience metrics, MOS scores, and other standards-based network layer measurements. While active testing does provide a detailed end-to-end and segmented view of network performance and acts as a consistent reference to detect and monitor QoE trends, it does not provide the visibility into the actual, in this particular case, VoLTE session itself, nor the signaling and the control, the actual signaling or control calls. So an active test relies on standards-based and a highly precise synthetic test traffic injection, but it must infer the service quality metrics from the network layer QoS measurements. So this is a good indicator of QoE, but it does not provide the whole picture. So that's where you want to complement active testing with passive testing, and that actually analyzes the actual, in this particular case, an actual voice call packet rather than the test traffic, and it enables the measurement of the actual user experience itself. So historically, there's been no practical way to pervasively and ubiquitously instrument the full network. Again, going back to the fact that this is a network-based service, it's not confined to a data center where you can you have ER span ports or fabrics that imitate the actual production network. And the reason for that is the cost of devices like and appliances like packet brokers, intelligent taps, and QoE DPI analyzers prohibits wide scale deployment and installations of that sort of instrumentation. So what you can see in this particular use case here is the result of a cost-efficient method to tap all the points of interest. So again, this is more distributed. It touches the eNode Bs to the EPC itself and all the points in between. And again, this is very helpful. It's a way to gain visibility to segment traffic. There's ways to do one-way measurements now between these different test points and test agents, reflection agents. But again, it requires a change to the way networks are instrumented, and it really becomes foundational to network control and a shift from a static, centralized kind of monitoring to more of a pervasive, ubiquitous telemetry.
All right. I do want to take just a second here as we're in the midst of our presentation and bring up our second poll. That's going to deal with analytics. And so audience, we want to get an idea of where you are in sort of an analytics journey as far as the network. And again, we'll leave that up and give you a chance to respond to that while we continue.
All right, thank you. So when it comes to the measurements and application of network quality of service and also subscriber quality of experience, it's really essential that instrumentation that we've been discussing, used in the roles of both policy control, for example, charging and enforcement, but also as we're talking analytics and business intelligence on the wireless operator network, that they have the capability and ability to inspect and classify accurately, especially when they're deployed over a virtual architecture and we're actually using a centralized systems. So these inspection and classification systems are really the foundation for accurate analytics, network policies, and even charging plan. Overall, you can't manage what you can't measure, and having informed decision requires really specific and accurate information. So beyond just knowing what a certain protocol is or what a certain application is on the operator's network, it's essential for the purposes of analytics and business intelligence to extract relevant information from all of these flows. So beyond going through sampling data, having the ability to really understand the consumption of different types of applications, the devices that drive the consumption of these applications, the type of media that are being watched, and for example, to the extent of the type of network that they flow over or the content delivery network that they actually leverage to deliver that content. Once we have all these extra information, the ability then to create both relatively simple charging plans or have really insight as to what drives consumption in specific areas of the network, either, for example, by the volume of certain application, the duration of these events, and then deriving really relevant, for example, metrics on the quality of experience for both VoIP as an OTT offering, for example, or even a VoLTE call, MOS scoring. That requires the proper tools to actually measure that. Beyond that, as we move into higher level applications such as video on demand, whether native to the operator or over the top, having the ability to actually derive the quality that the experience is, as was mentioned earlier, Now, there's a notion that video delivery on the wireless network has its issues, but what are those issues, and how can they be remediated by the operator becomes an important fact that can be revealed through business intelligence. Other quality of experience measurements, such as the ability to understand why some customer may actually shift off of certain websites and not other, understanding the time to load page from WebKits, for example, that are present on portable devices, and understand how the network can be optimized to actually deliver quality of experience that really bests the application that are used to render them. Next slide, please. So in order to do that, a policy control system needs to rely on the foundations of state by the subscriber, the network, and a charging environment. And a policy engine really must have the ability to look in real time to both conditions and entitlement that are on the network that are seen by the devices, and also understand a subscriber state. So an example of this is where is a subscriber located on the mobile network as part of the RNC, for example, what type of device type it is, and what type of application, and also what is the quality of these measurements as we see them on the network. Subscriber entitlement then complements this behavior by understanding the service tier that the user is on, whether the subscriber has quota for these applications, whether quota is on or off and running out, and understanding the add-ons that the subscriber may be provisioning as bolt-on services to deliver extra capacity to these devices. So once we understand that, we can actually then have an idea of the subscriber state or history of the subscriber. Is there a trend occurring for my subscribers watching video? Is the quality of experience improving over time? Is it stable, or is it decreasing in times of congestion? So all of these history-based decisions come into effect here to deliver better quality, and that can be driven by the software-defined network to actually change quality of service metrics on the network. Ultimately, the outputs of a policy engine that does analytics can be passive or active. So we can have billing and charging environment where we can actually send these updates of the consumption for the subscriber that need to be byte accurate, again, where the instrumentation needs to be extremely accurate. It can be to feed into a data warehouse for business intelligence so that the right type of data is being represented to the budget owners and to the network operators. And finally, actions that can be done to improve the quality of service or even better the quality of experience. So we can certainly count and measure all of these bytes, all of the drops and the quality. And then indirectly, we can actually mark our signal to upstream devices. We can actually push commands through a northbound API to an SDN controller to enforce different types of quality on different flows. We can also actively, as a PCEF or an enforcement function, apply the proper type of rule sets that lift the quality of experience overall for the subscriber on the applications that they do use actively, while, for example, sending to a queue applications that run in the background, such as an application update, for example, that may be running while the phone is actually busy doing other active applications like video streaming. Ultimately, we can also tee to measurement security apparatuses, or we can even divert to third-party applications like video optimization. So all of these 5 foundations are critical in a instrumentation of a network operator in 4G and in the future to really lift up the quality of service, the quality of experience, and have really byte-accurate billing and charging that reflect the subscriber's experience on the mobile network. Next slide, please. And when it comes to actually detecting application and applying QoS, we can think of security as an extension of that. It's a logical extension that malware or, for example, botnet or DDoS attacks have a certain network behavior, a certain network heuristics that can be detected as if they were applications. Obviously, applications of a different type, being malicious, but nonetheless, an instrument that is deployed on the network can be used to actually differentiate and separate legitimate traffic that is coming from the user equipment on the wireless network from the malicious one. So whether we have an active web browser browser that is actually watching completely legitimate websites, or we have a phishing attack ongoing where we actually see the the malicious intent that is being done by a remote site on the network. So the ability to both do that directly is important in the instrumentation in detecting these activities and securing the network, but also to partner up with companies that are security focused. The examples, for example, of the semantics of the world, where botnets, command and control channels with zero-day relevance can be stopped on the network to protect both the infected device, but also the clean devices that may be inadvertently impacted by the network activity. So understanding that security and instrumentation can work together, both like Michael and was mentioning with active testing, that once we have these instruments, we can actually then understand the behavior of the network by using active testing and actually trying to certify the network being resistant to some of these attacks. Next slide, please.
So I think Nick and I are going to walk through this particular VLE QoE assurance use case. So what we have here is basically a typical, on the left side, a typical VLE deployment where you have your EPC, and then you have, of course, the MNOs and so forth out there, highly distributed network. And at probably the core location, if you kind of slide over to the right side of this particular slide, you'd see where you see the Sandvine policy control engine that would be centrally located. Now, without any other instrumentation in the mobile network, the only place that policy engine can capture and detect and analyze would be the data that it would receive at back at this centralized location, most likely somewhere in the EPC area. And so the activity and the network performance that's taking place out in the distributed part of the network between the MNOs and so forth, you would be pretty much blind to at that point. So what we did as actually demoed at Mobile World Congress in a POC was to provide and extend the visibility of this policy control engine to the most remote parts of a mobile network using our virtualized instrumentation. And so it's virtualized because we have a centralized control plane, and that's what you see as VCX. That's our controller. And what we have at the endpoints it's a solution called Flow Broker, which is basically a virtualized packet broker. And what we could do is we could go out to these endpoints, and upon command into the controller that the policy control engine could provide, we can classify traffic. So we can classify traffic based on user, based on TCP port number, IP address, MAC address. And then we slice the traffic of interest. We bundle it. We losslessly transport it and transmit it back using TCP to the centralized controller, and then we can reconstruct the flow, and that's where we can do things like count it, store it, and send it to the Sandvine policy control engine for analysis. And so what we have done here is now we've actually created visibility. So if there are network performance problems that are, let's say, east-west between, for example, the two MNOs at the bottom, you would now be able to detect that because we now actually have instrumented the network to be able to provide that ubiquitous visibility or what we're calling pervasive telemetry all throughout. And this is really going to be important, again, as networks become virtualized, and even for networks that are not virtualized today, to provide this sort of visibility. So Nick, I'll turn it over to you there.
Yeah, thanks, Michael. So as you mentioned, the partnership that Sandvine and Accedian had together at Mobile World Congress really highlighted the flexibility of our respective solutions really to interoperate together. As you see little Sandvine leaves there in a packet core, typically the traffic detection function the charging function and enforcement function have their set point of installation and deployment within the packet core. What we really wanted to highlight was with a virtual series deployment, which is the virtual network function of Sandvine, we could deploy the actual function anywhere within a data center and interoperate with the VCX controller and the packet, the flow broker, to actually then instantiate captures and replays in real time from any point in a network. So once we detect, for example, whether it's security, QoS, or QoE event in the packet core, we can go back into the network at any level from the radio to the ENOB, for example, and instantiate a centralized Sandvine virtual stack, and then replay in real time the captures that are being done in specific points on the network, preserving essential information like machine timestamp, where the actual jitter and latency that's experienced in the field is actually observed up in the cloud, and then have a complete visibility by the instrument that complements the traffic detection function and enforcement function for both policy control and analytics. So this was a really powerful talk that we did, and I was really happy to partner up with Accedian for this, because it for the first time showed extreme visibility at any point in a network, regardless of where the Sandvine solution is deployed in the cloud.
Great. Well, then let's move into our conclusions. We've been talking about networks and traffic patterns getting more dynamic, dense, and complex, with video in particular driving significant utilization. That the coexistence of all these applications challenges quality of experience. We also have optimizing use of the network, and QoE will rely on real-time ubiquitous visibility at all locations and layers, which, I think we heard from Michael and Nick, how you can accomplish that. Analytics will definitely be employed to derive network policies and control from virtualized instrumentation. And then operators moving toward 5G networks have already built in these capabilities. And again, as we had Patrick talking about, and this is really following a path of leading cloud service providers. So as we get into our Q&A, please remember to submit your questions. I see that some of you already have, so I appreciate that. And so, gentlemen, I want to start us off, with a question about agility. And this is something we've been talking about. I think we have some really good examples. The Volti use case, I think, was particularly interesting. Can we talk a little bit about this concept of agility? What does that really mean as a practical matter for the network? And can you talk a little bit about the value and what can be accomplished in this? Do you see impacts of agility coming to the top line, bottom line, or both? And I don't know if, Michael, you might want to start with that one.
Can you repeat it, the question again?
Yeah, sure. Let's talk a little bit about what agility means as a practical matter for the network, and what the value is in having this kind of approach, that's analytics based, that's hopefully really offers that level of visibility that we've been talking about.
Right. So again, if you think about agility being the ability for the network to automatically configure and control itself, you really are thinking about almost, if you're familiar with any kind of classical control theory, the ability to have a kind of a centralized controller, and that's our control plane, and then the instrumentation it becomes the feedback loop that then compares the true network or the real-time network state to the desired network state, and then there's a tuning process that would go on within the network control plane to constantly update and manage and control the network to deliver on the type of performance that it needs to deliver. And as we mentioned, that would take place on a per service as we look at the complexity and the different requirements. Going back to that early slide that you showed, IoT traffic is perhaps very low bandwidth, but needs to be highly available, whereas video is high bandwidth, but can handle some more latency. And so all these different service network or network service requirements are being imposed upon the same pipe. So all of the control mechanism for that would reside in the control plane and the policy, even in the analytics, because what we have nowadays is you're not just limited to the network performance metrics as part of your data set, but there are now even feeds of social media feeds, for example, that could inform the network control plane that all of a sudden we have a massive rise in traffic in a certain geography. Some team wins a national championship game and everybody barges into the street, and you have all of a sudden out of nowhere 3,000 or 4,000 people trying to tweet and Instagram and text photos, all hitting the network dynamically. You need an environment or a network infrastructure, an architecture that can instrument that and then send that to a control plane that can scale to that. So the scalability, the agility, and the network service elasticity all have to be there.
Okay. Any other thoughts from our panelists on the value of agility?
Yes, this is Patrick here. I think agility is probably one of the most difficult objectives to attain when it comes to SDN and FV. And maybe not a lot of people realize what impact that has on their network or is about to have on their network. I think Cisco projected that the busy hour growth over the next 5 years was going to increase by close to 60%, I believe, or 80%. So it means the variation between the network at its normal load and the network at its peak is going to increase. And the traditional way to provision network capacity has been to over provision. So if you need, and I'm going to take just numbers here for reference, if you need a network that is able to manage 100 phone calls at a peak, then you're going to provision for 120 or 130. But what we're seeing is that number, that 100, is growing to 150 to 180 within the next 5 years. And what that means is that a network is not going to provision 200 phone call capacity if in average the network supports only, let's say, 80, and an hour a day or a few times a week it goes up tremendously. So the agility here is the ability to be able to follow the curve and follow the demand without having to over provision your network. And I think that's probably one key attribute of virtualized and software-defined networks. The corollary being that if you want to have a network that is going to be very agile, we're not talking about human scale here. We're not talking about people being able to see that, oh, there's a spike in the network, or we need to provision this and provision that. It needs to be highly automated. So quality of experience and measurement and telemetry are key to make a network agile.
Okay, great. We did have another question here from our audience, and that was, will this kind of visibility be part of self-organizing networks and reduction in drive testing? And I think it's important to note that, that in terms of standards, reduction in drive testing is something that is being looked at and developed, and that this ability for more visibility and for more automation without a human element, as you mentioned, is something that that the ecosystem in general, I think, seems to be moving toward. Any other thoughts on that from the panel? Okay, great. Well, I think Nick, I wanted to ask you a quick question on how encryption was impacting networks and what that means for visibility and agility. Both you and Patrick mentioned, the extent to which encryption is becoming part of, a significant percentage of network traffic. Thoughts on what that means for, for visibility and agility?
Sure. So obviously there's concerns about encryption and instrumentation. Late last year, we published a global internet phenomena spotlight specifically on the rise of encrypted traffic on the internet. And there's really two concepts that we brought forward. Is the use of encryption as a privacy measure versus the use of encryption as a means of obfuscation. So in the first one, privacy measure is really about protecting the content through, for example, digital rights management or protecting the actual visibility of the content. That's really around the concepts of privacy for the user, and that is something that needs to be respected on all the networks. That doesn't mean, however, that it cannot be measured, that the quality cannot be inferred actively, and that the type of traffic that flows on the network can no longer be seen through proper instrumentations. There are extensions to HTTPS, for example, secure HTTP, that really help actually solidify the type of measurement of quality through, for example, SNI or server name information. When we talk about obfuscation on the second part is really people trying to hide their identity themselves. So these are typically done through VPN services, for example, and the accepted standards that they use are still fully visible. So we still understand people using these services. You still understand the quality that they're using, but the application beneath it can be inferred through some machine learning of heuristics as they're seen on the wire. But the real story here is that the growth of the encrypted traffic has been done through very selective partners that have activated secure content delivery, like YouTube, for example, or Google Mail, through HTTPS or even speedy or quick or speedy proxies. But these continuously are being identified properly, and it really helps our operator measure the type of usage that's being done over these services, whether they're encrypted or not. The operator are not necessarily after the content; they're after the network behavior that these applications drive.
Okay.
And if I might add to that, sorry,
Yeah.
Patrick, I think it's important to realize probably that the growth of encryption and the fact that operators have difficulty identifying and managing that traffic are somewhat decorrelated from, I was mentioning net neutrality and privacy issue. I think at this point in time, there are certainly methods that allow a network operator to see when the traffic is encrypted, what type of traffic is going through anyways. We just mentioned heuristics, and certainly you can look at packet length as well as pattern recognition in terms of the packets exchange to divine what is going on within the encrypted traffic. But more importantly, we have seen collaboration between content providers, content aggregators, and CDNs and caching companies to provide means to identify what is within the traffic. And I mean, you don't need to decrypt the traffic to know what is within the traffic. It is just a matter of providing the right metadata that could go through the HTTPS or through the SSL headers. So from my perspective, I think that, as we're seeing more and more collaborations between content providers and mobile network operators, we will see more and more, operators will regain visibility in terms of what is within the encrypted traffic without necessarily having to see the traffic itself. And that would provide means for control, both on the content provider side and on the network operator side.
Okay. Well, gentlemen, thank you so much for the program today. Audience, thank you for your participation. And we're going to wrap up here. Thank you so much for joining us today.